You may in your woodworking have run into a problem that I've run into, which has to do with dimensions of parts. So what I'm talking about is stuff like 3/4 inch sheet goods, or any thickness for that matter, that aren't true to that thickness. Cutting tools like router bits that sometimes even when they're brand new, the tolerance is a little bit iffy. Certainly once you sharpen a bit, it's no longer the diameter that it was when it started. Now, the problem we run into with that is that when we do joinery, and we want good quality joinery, that means we want those parts to come together with a really good fit. And that becomes very difficult to predict if everything is iffy dimensionally. So what it really comes down to is having a router accessory that'll let you do the joinery here at the bench using your handheld router and dial in the size of the joint that you need to get a perfect fit from the machine. Now the other thing that comes out of this is a benefit to using a handheld router like we're going to do today is that with some projects it's easier to take the tool to the work than the work to the tool. So this case side I've got on the table is a pretty good sized chunk of plywood, and it's easier to work it with a router here than to manipulate it on the table saw to do dados. And a dado is what I'm going to work on across the carcass side here. I want to cut a dado that'll accept this 3/4 inch shelf. Now I'm not using a 3/4 inch bit, I'm using a 1/2 inch bit, and that's going to make sense in just a little bit after I get done with my first cut. So with my fence set and the router ready to go, I'm going to plow a preliminary pass across my case side here. Now we already know that the plywood's not going to go in there, but what we need to figure out is what we need to do for a correction. What do we need to do to make a good joint? So step one, I'm going to measure the size of the dado that I just produced, starting out with making sure that my calipers are clean and zeroed so I can read them, and I want my calipers to be in decimal inches. The width of that dado from my 1/2 inch bit is actually 498 is what I'm going to say. The material that we want to put in there is oversized because 3/4 of an inch would be 750 thousandths. This is 763. So here's what we need to do. We've got an undersized dado because it's not even the 1/2 inch that's the diameter of my cutter. We're going to start with the dimension of our plywood and put that into our calculator here, 0.763. From it, we're going to subtract the existing width of our dado, minus 0.498. 0.265 is the change we need to effect to get this piece of plywood to fit into the dado. How do we do that? Well, it comes back to that router accessory, the router setup I was talking about. Here's what we've got going on the router. What I can do is make a change in my fence of the number that we just calculated, 265. So on the dial here, this measures out thousandths of an inch. So we need to change 265 thousandths, just over 1/4 of an inch. Every turn of the dial is going to be 50 thousandths. Going to keep that part locked down, unlock this part, make a change. 50, 100, 150, 200, 250, 5, 10, that's 260, 5. Now we're going to add just a little wiggle room there so when we put it together, we don't have to drive it together with a mallet. I'm going to add another 5 thousandths for that. And then we're ready to make another pass in order to take the rest of the waste out of there and have a dado that fits. With that ability to dial in our different sizes, we can get a fit between the shelf and the case side that's going to make for a very substantially strong dado joint. So this is a pretty common application for that router fixture. Let me show you another one. All right, here's what's cooking in this case. Look at this cool box that's got these great pieces in here that I carefully cut one by one and put in there. No, these come as inlay bands that you can put into projects like this. They really add a beautiful detail to the project. This is what I want to show you here. I've got another piece of inlay band, and we run into the same problem here you do with sheet goods, which is, although these are called some given dimension, generally, they're not exactly that dimension. Same with our router bit. We don't know what size we're getting there. So let's see how all of this comes together. We're going to use the same technique, which will be to make sure we're zeroed, measure the groove we just created, runs in the same direction as the grain, so that makes it a groove instead of a dado. 2, 6, let me get where I can see what I'm looking at. 2, 6, 8. So it's funny, on our last one, the 1/2 inch bit was undersized, my 1/4 inch bit is oversized. So 2, 6, 8 on the cutter, and 0.30 on the inlay. 0.30, 268, 0.30, 268, calculator. 0.30 minus 0.268. A net difference of 32 thousandths of an inch. So we're going to finesse this baby in the same way we did earlier. I'm going to effect a change of 32 thousandths from our starting point there. So I'm at about 11 right now. So we would swing this up to 43. And then same thing, I'm going to add myself just a couple thou of wiggle room, lock that in, and finish the pass. Now, inlay, going right down into that groove we cut in our maple. And what a pretty contrast that is too between this particular piece and that really, really white maple I'm working with. Great way to get these parts to come together in a perfect fit. So a couple different things I showed you here today, but remember, just think about any time we're making a groove or a mortise or a dado, and you really want a good fit there so the parts come together well and your project can stand up over the test of time. It all comes down to dialing those precision dimensions in off of a good router accessory that allows you to have that kind of precision and bring it into your woodworking projects.